All right, so the world record for the women's 400-meter race is 47.6 seconds. The world record for the men's 400-meter race is 43.18 seconds. How much faster is the men's world record time than the women's world record time? So I want to go back through, and I know some of you are already, you know how to do it, but some of us struggle with story problems, so I'm going to go through and read it one more time and talk about getting rid of information we don't need. The world record for the women's 400-meter race is 47.6 seconds. What part of that sentence is important? Raise your hand, TJ. 47.6. Do I really need to know that it was 400 meters?
No.
No, I need to know that these are the same, but I can cross that off. I can black that out entirely. That's an extra number that's in there that I don't need. The world record for the men's 400-meter race is 43.18 seconds. So that is something we need. I don't need to know this number. When you see extra numbers in there that are not actually important, sometimes it's good to cross those off. We just got rid of it. We know it's 400 meters, but we didn't really need that for this problem. So for you guys that do track, 400 meters, what does that look like, Red?
It's one lap.
One complete loop. So each of them are doing a complete loop. So if you want to think about it, so the woman who held the record did one complete loop around the track in 47.6 seconds. And then the man that has the record went in 43.18 seconds. So I just kind of drew a picture. I'm not working it out on this page. I'm just kind of getting in my mind, okay, that's one loop around the track, that's one loop around the track. It's the same distance, but they did it in different times. It is really fast, I agree. To do 400 meters might take me minutes. I don't know. I haven't tried it in a long time. So what we're going to do with this information, and for some of you it's going to drive you crazy because you already know how to do it, is we're going to go through these steps. We need to go through the steps with the easy problems so that we know how to do them with the harder problems. So first we're going to write a number sentence. So to do it's not really a number sentence, it's going to be more of a phrase. But we need to figure out, it asks how much faster is the men's world record than the women's. What operation are we using? Addition, subtraction, multiply, or divide? Okay, Bennett raised his hand. Subtraction. So we know we're going to subtract. So that's going to be 47.6 minus 43.18. I'm not working it out. I'm just writing that down. If I want to make it a sentence, I could put equals diff for the difference. If I just want to make that into a sentence, okay? So that's all I'm looking for is you're just going to write down, okay, that I know I need to do this. Now, we're going to estimate to kind of figure out what this should be before we actually do the work. So when you're estimating with decimals, what's nice is to round it off to a whole number. So 47.6, if I round that off to a whole number, what is that? Yes, Jaden. Whole number, 47.6. Alyssa?
48.
48. So I'm going to write down 48. And then 43.18, if I round that off to a whole number, what would that be? Go ahead.
44.
Well, since it's 0.1, would I want to round it up?
Nope.
No, I'd want to leave it at 43. So all I did was round those to whole numbers. Can I very easily subtract that as my estimate? Yeah, so I'm going to get 5. So I know there's about 5 seconds of difference. A lot of times when we're estimating, we're doing that in our heads. We're going to actually do it on the paper just so that, because some of these, especially when we get to division problems, you're going to be like, I don't know if I did this right or not. Estimation is a big skill. Okay? Now, we're going to work this out without a calculator and show all of our work. These boxes are not huge. You're going to have to write small and neat. Okay? And if for some reason you couldn't fit it in the box, you would take a piece of notebook paper, if this were an assignment, and write A1 or 1A or whatever that's supposed to be, and work it out. But I think we'll have room if we just write small. So we knew we were doing 47.6, and we're going to subtract 43.18. So when we're subtracting or adding, we line up the decimals. We talked about that a lot a couple of weeks ago. What do I do if there's not a digit right here? Raise your hand if you know. Go ahead.
Would you add a 0?
You would put a 0. You want them to have the same number of digits when you're adding and subtracting, because I have to have something to subtract the 8 from. All right, I can't take 0 minus 8. Well, I could, but I'd get integers. I don't want to do that. So let's let somebody else try. So somebody who hasn't answered me in a while, what do I do with that? Bennett.
You take from the 6.
Take from the 6. Borrow from the 6, which makes it 5. I'm going to bring a 1 over here and make that 10. Good. You guys know this. I just feel like you need the review. Okay, so 10 minus 8 is 2. And then 5 minus 1 is 4. Make sure I put the decimal point. Some of you are really bad about leaving that out. And then 7 minus 3 is 4. And 4 minus 4 would just be 0. So I think my answer is 4.42. Now I should label this. How are we measuring the time for these 400 meters? Seconds. So I should probably put seconds, either an S or an SEC or something on there to show that this was seconds. Now, this last box, I'm going to do it with my calculator. Okay? And so we get to use the calculators a little bit. This is just a check. 47.6 minus 43.18 equals 4.42. And it says use your calculator to check your answer. Write out calculator answer. I'm just going to put 4.42. And then I'm going to put a check mark next to that came out okay. Now, if I did this and didn't get the same answer over here, what should I do if this is an assignment? Should go back and rework this, showing me all of your work. So when we turn these in, no one should miss anything. It's a skill to know how to estimate your answer, and then I can also use my estimate. Is that pretty close to 5 seconds? Yes. So not only have I estimated, I checked it with the calculator. These are really powerful skills. You should know when you turn in your math work whether you did it right. You should know. You shouldn't have to use my answer key to check or ask me to check it. This is skills as you guys are thinking about 8th grade next year and then high school for some of you 2 years from now. Yeah. You have to know how to check your own work. It's really important, okay? So we did number 1. I know it took a while. It's going to speed up a little bit, but like I said, this is going to take us a couple days. It's okay. So let's go back. Let's look at number 2. All right. So we're still looking at races. All of these 3 problems go together, and then it changes me. So there was supposed to be an A on here, and evidently I cut that off. I just realized. So 1, 2, and 3 are all supposed to be with part A. Oops, I cut that off. All right, so suppose that the men's and women's world record holders were to run an 800-meter race. So they're talking about the people up here that were running 400s at their winning speed. So we're just pretending that they could run it at the record speeds. The women's record holder runs 400 meters and then tags the men's record holder who runs the last 400. So like they're doing like a relay between the 2 fastest people, whoever ran the 400 to do an 800. Does that make sense? So think about your track. So they're going to have the lady go all the way around. She's going to pass a baton or tag the other guy. He's going to go all the way around to get a total of 800. So 800 is 2 laps. Okay, how long would it take them to run the total distance of 800 meters? So she's running 400, he's running 400. Does it really matter? Do these numbers really going to matter in how I'm going to work out my problem? No. What numbers do I actually need to work? The numbers from up here. I have to go back to number 1. These numbers are just making sure I understand what's happening. They're doing 800 total, but they're each doing 1 lap, 400 and 400. Okay? So what we're actually going to do is we're going to take their times and add them. Okay?
Oh, that's simple.
Yeah, it is pretty, but we're still going to go through our steps. So we're going to come over here, same numbers. And so 47.6 plus 43.18. It bothered me that the book called this a number sentence without an equal sign, so I'm going to put equals total. Just so it's actually a full sentence. It's like having a sentence with only the noun. I don't know. So that's just, we know what we're going to do. We know we're going to add. We're just writing that out. We're going to estimate a little bit. We can use the same numbers we used on part 1. So we can just round off to 48 and 43. Is that going to be super easy to add?
Yes. Yes.
It's not too bad. Like we could add it. I still might need a piece of paper because I have to carry. So 8 plus 3 is 11. Carry it. 4 plus 4 is 8. Plus 1 is 9. Although if I were doing this like in my head, if I was wanting to estimate on something that I wasn't required to do it on the paper, I might round these off even more. I might round 48 off to, I might round this to the nearest 10 and say, oh, 50 and 40. And look, that's still not a bad estimate. So there's a little bit of, you have a little bit of choice with the rounding. Like, just taking the decimals off definitely makes it easier. But this makes it super easy, and they're not that much different from each other, okay? So both of those would be good estimates. I would take either one of those. All right, so now we're going to do this for real. We're going to take the real numbers, 47.6, and add 43.18. And again, we don't have a number here, so we're going to put that 0 in. Yes.
It's 90.78.
Okay, so you've worked it out. All right, so 0 plus 8 is 8. 6 plus 1 is 7, so that wasn't bad. Remember to line up your decimals and put the decimal in your answer. Some of you forget, which changes the number quite a bit. 7 plus 3 is 10, so we put down the 0, carry the 1. 4 plus 4 is 8, plus 1 is 9. So let's just look, even if I haven't checked it with the calculator, do you think we probably did it right, or at least really close? Yeah, we're totally close to both of those estimates. And remember that we're measuring this in seconds, so if this is my answer that I'm boxing in here, I'm going to label that with seconds, because it's important we know that this is seconds and not minutes. Minutes would be if I ran 800 meters. 90 minutes, I might make the 2 laps. But if these are the world record holders, they're doing that in seconds. It's about 1.5 minutes. Okay? You have a question?
So they ran an 800 in 1 minute and 30 seconds.
Well, it's saying that they could, if they did their record times. Now, are they going to actually be able to do their record times? Maybe. They'd be close. So it's kind of an interesting thing to think about. I think they're just trying to make an interesting story problem out of it. All right, so now we're going to check this with our calculators. So we're actually going to take the problems and do 47.6, and we're going to add 43.18, and we get 90.78. So since we got it right, I'm just going to write down what the calculator gave me. And this is just basically showing that they came out the same. And if they didn't come out the same, like I said, if this were an assignment, I'd go back and make this so it did come out the same. You can also, these calculators, if it didn't come out the same, the first thing I would look at is this top line to make sure I typed it in correctly. Sometimes when people go, oh, this didn't come out the same, and they go and erase everything and rework it, like, make sure you typed it in right, because that would be the first thing I would check. Did I type it in right? Yeah, okay. So then it must be my work that's wrong. Okay? Yes. All right, so let's go look at A3. All of these are about racing, which is cool because we're in track season. It just worked out. All right, so if the women's world record holder ran the 400-meter race at a constant speed, so basically we're thinking she's still running her record speed, how long did it take her to reach each 100-meter segment of the race? Now this is one we definitely want a little picture on. So think about the track. I'm not good at drawing, but you know, it's kind of elliptical, sort of. So it's 400 meters all the way around. You could think of that as sort of a circumference, except it's not a circle. That's the distance all the way around. Okay? And we know how long it took her to do that. It was 47.6 seconds. But they're wanting to know how long it took her if she ran it. Now, we all know, because a lot of you are in track, that you're going to kick at the end and all of that. What if she was just a robot and she was running exactly the same speed all the way around? So they're breaking this into hundreds. So basically, we're going to divide this up into 4 sections. So here's 100, here's 100, here's 100, and here's 100. So they want to know if this is the time for all the way around, how long it took her to do each of these little 100 legs. What do you think?
To get the answer, I think we'll have to divide by
I think we'll have to divide. I even said the word divide when I was drawing these little lines on here saying we're going to divide it up. This is why a picture is super powerful. It can help you think through the problem. You want to make sense of the problem before you go on to work it up. And if you need to read it several times, that's also good. We went through and we read it. She's running 400-meter race at a constant speed. It's kind of important that it's constant. We don't usually think of that as being constant all the way around. How long did it take her to run each 100-meter segment? So we needed to have those hundreds and have this in our minds, really understand the problem before we try to just do something. Sometimes I think people are like, I don't know, I guess I'll add the numbers, and I get these weird things turned in. Really think about it. Draw it out really quick. All right, so let's go over here. So we said we're going to divide. What are we going to divide?
Ooh.
Okay, go ahead. We need to get somebody else to
I think
volunteer.
we're going to divide the 47.6 divided by 0.25 because that's a fourth.
It is a fourth, but a fourth is the same thing as dividing by 4. So we really want to think about exactly what we were doing. Were we dividing these into were they're 0.5? The point, I get what you're getting, that's 0.25, but we divided into 1, 2, 3, 4 pieces. So you need to think about that 47.6 as being the total. And so you're actually dividing it into 4 pieces. And they don't give us the 4 in the problem, which is why I think this is so complicated for our brains. We have to come up with the number 4. Well, if it's 400 all the way around and we're dividing it into 100 segments, we're dividing it into 4 legs, is what they usually call it, 4 pieces. So we're going to take this time and divide it by 4. And I think if you divided by 0.25, you would have figured out really quickly that it wasn't right, because you would have got a really weird big answer.
You can do times 0.25.
You could, if you really wanted to. I think this will be easier. All right, so if we're estimating this, we want to round this off to something that's easy to divide by 4. So I think if we just round this off to a whole number, because they were nice to us, and we just did 48 and divided by 4. So this, if I wrote it this way, it'd be 47.6 divided by 4. So I just rounded this off to a whole number. I think that'll be not so bad, because 4 goes into 4 one time, you subtract, you get 8. 4 goes into 8 twice. So you could really quickly divide that. That's like long division 101. You guys have been doing those kinds of division problems for a very long time. And so we come out with about 12 as our estimate. So about 12 seconds for each leg. Okay, so we're going to come over here. We're going to do it for real. So 47.6 divided by 4. Make sure you're leaving a tiny bit of room at the top for your answer, but you need to write super small. You know what also you might want to do? Do you see how this box is wider this way than this way? If you needed to turn it sideways to get it to fit, you may have to do that, because these take a little bit of time. You're going to have to write small. You're going to have to write neatly. All right, so 4 goes into 4 one time. That part's the same as what we did with the estimation. 1 times 4 is 4. We subtract. What do we do next? Raise your hand. Jaden, you've answered a lot, and I'm super appreciative. I don't know if it's because your mom's watching or what, but okay, Tommy, go ahead.
You put the 0 at the bottom and then you bring down 7.
Okay, so I'm going to put the 7 there, and yeah, you can put a 0 there. And then do you want to help me out? How many times does 4 go into 7? Uno, 1 time. So I'm going to put a 1 up there. 1 times 4 is 4. We subtract. 7 minus 4 is 3. Then we've got the 6 we got to bring all the way down. We are almost done. I'm just going to barely squeeze it in. So, oh, and remember that the decimal point here needs to come up here. Some of the papers that I graded yesterday with our long division, you guys are forgetting decimal points or putting them in weird places. It just goes straight up. All right, so how many times does 4 go into 36? Johnny?
9.
9, good job. So the 9's going to go here. 9 times 4 is 36. If we subtract that, we get 0. I'm going to kind of slant to the side. So we know we're done because we didn't have any remainder after that. We have 11.9. Is that close to our estimate of 12?
Yep.
Super close. So we're pretty confident we did it right, or we're at least close. So then when we come over and do this with our calculator, I'm going to type it in like it was set up originally. 47.6 divided by 4, and we get 11.9. You can't, I have to tip it to make it show up really good. So we get 11.9, and if we did that right, we can check it off and keep going. Okay, we're going to try to get through at least one more of these. The more we get done today, the more time you'll have to do the assignment tomorrow in class. And then if people are here on Friday, they'll have some time to work, but we won't be in class to do it. The schedule's a little crazy for Friday. Although I'm kind of asking if we can change a few things, because I'm not supposed to have these guys at all on Friday, the way it's written up. I think so. So I think they have them down to be with Cameron. Like, if we could find time for them to come work with me. So I'm sending things to Leslie to ask.
Wait,
because
what are we doing on Thursday?
On what?
Thursday.
Tomorrow is Thursday.
Normal.
We're gonna finish this. This is gonna take us 2 days to get through.
And then what are we doing on Friday?
On Friday, there's a track meet, and there will be a few people here, and they'll probably, you guys are going to have homework tomorrow, because I doubt we get this done and the entire assignment. So if you're here Friday, you'll have time at some point during the day to work on that, and hopefully a chance to come touch base with me. All right, so on B, Pedro buys 7.5 gallons of gasoline for $28.49. How much does each gallon of gasoline cost? Okay, so I'm going to draw a picture. You guys, hopefully you won't laugh at me, but if you do, it won't hurt my feelings. I'm okay. So I'm going to draw a gas can. I'm going to try. Okay, so have any of you guys ever ran out of gas and had to take a gas can and walk?
No.
My dad used to do that all the time. Our old farm truck, we would coast into town sometimes barely. So it has like this long nozzle thing, and it's a gas can. Anyway, okay. So we're buying 7.5 gallons. It's a big gas can. You wouldn't want to carry it very far.
No.
I have seen 10-gallon gas cans, but I could not have lifted them. And so for this whole thing, we're paying $28.49. Okay, so that's how much, it rings up on the little gas pump. Hopefully you guys have watched somebody pump gas. But for some reason, we don't know how much each gallon costs. Sometimes the little digital things, you can't read it. But you need gas, so you're just going to pay for it anyway because you ran out somewhere. All right, so it wants to know how much does each gallon of gasoline cost. So this is how my brain works. I'm going to take this and draw a little picture, and I'm going to divide this up into little gallons. I'm just going to draw a little box. I'm going to call this 1 gallon, and then I'm going to have another one, so that's 2 gallons, and then another one is 3 gallons, another one is 4, I'm going to have to put some over here, 5, 6, 7, and then I have a 0.5, which would be a half, so I'm going to draw that as a 0.5. So I'm dividing this 7.5 up into individual things, and it's wanting to know if this money was divided up into each gallon, how much you would pay for each gallon. And I just kind of gave away what we're going to do. What operation are we going to use? Divide. When I draw this picture and I think of it as splitting it up, then it becomes easy for me to think, oh, we're dividing. Okay? So we're going to take this number and divide by this number. So over here we'll write out what we're doing. So it's 28.49 divided by 7.5. Some exciting decimals happening there. And then I could put equals the dollars per gallon or something like that, just so we have some idea. I don't like the idea of a number sentence that isn't actually got an equal sign in it, but if we at least get the operation down, I think that's the point of this. So now we're going to estimate. So we have to think about how we could round these numbers off into something that we can divide. So let's first just try to do whole numbers. So 28, if I round it to a whole number, 28.49, if I round to a whole number, would just be 28. Okay, but if I round this up to 8, it won't divide evenly. So I'm going to kind of break the rounding rules a little bit, and I'm going to round it down to 7, because that makes it a multiplication fact, a division fact that we should know, right? You guys see what I did?
Yes.
So 28 divided by 7 should give me about 4. Now I have to keep in my mind that I rounded this down instead of up. So this might be a little bit off. But I wanted to make this, the whole idea of estimation is picking easy numbers you can divide. Pick easy numbers, make it easier, make it something that would be in a multiplication chart or in those facts that we just have in our brain. Okay? So does that make sense? Question?
You should get a mark for breaking the...
Oh, I should get a mark for breaking the rounding rules?
Yeah.
So when you're estimating those, sometimes you do have to round one up and one down. just to make the math easier. And so it's a little bit different than just straight rounding. I know, it kind of hurts my heart too. But if I made that 8, it wasn't going to divide evenly. It wasn't going to be that much easier than doing the actual problem. All right, so this is a big long division problem. And it's okay. We're probably going to go down into the next box a little bit. It'll be fine because that next box won't be quite so bad. So what we're going to do is we're going to set up our division. So over here where I have a little bit of space, I'm going to go ahead and set up what the long division would look like so that I don't have to do that in my other box because I'm going to need some room. So remember, you kind of switch the order. The 7.5 is going to come on the outside, 28.49 is on the inside, and it sort of looks like we switched the order that you have the numbers. And so, do I need to move any decimals? Raise your hand if you know. Yes.
Yes, you do.
Okay, so I'm going to need to move this decimal one place. That's going to make it 75. Now, I can only move this decimal one place. So I'm going to have 284.9. I'm still going to have a decimal on the inside, and that's okay. All right? So I'm going to take this and rewrite it over here. I'm going to put the 75 on the outside, 284.9 on the inside. Okay, so this is a little bit scary, but here's what we can think about. 75s are like having 3/4. So really, it's not going to be super bad if we're thinking about it that way. Okay? Now, does 75 go into 2? No. If you want to put a 0 there just to know that you've already dealt with the 2, that's fine. Sometimes I just go ahead and move it over, but I think that may confuse you. Will 75 go into 28?
No.
No. So if you want to put a 0 there to hold that place, that's fine. Will it go into 284?
Yes.
Yes. So if you have a little space on the side, I might just kind of think about, okay, I don't know 75s. That's not like a multiplication fact that I've memorized. But I do know about quarters. So 75 cents is 3/4. If I double that, I have 6/4. How much money is that? Yes.
Go into it 4 times.
Okay, that wasn't what I was asking though. So think about if I had, so 75 cents, if I take it times 2, if I had 3/4 and 3 more quarters, think about in your mind what that would be.
3 times. Yeah.
Okay, but I'm not there yet. So what do you think? It'd be at 150, right? That doesn't seem close enough to me, so I'm going to go ahead and try 3. So if I add 75 to that, or just take it times 3, then I'm going to have 5 times 3 is 15. Put down the 5, carry the 1. 7 times 3 is 21, plus 1 is 22. Is that closer? Am I going to be able to add another 75 and still say under 284? No. So 3 is what I want to use, and I put the 3 above the 4 because I'm using the whole number 284. It's important that you're lining that up. It's also important that we put a decimal point after that 3 to line it up with what's here, because as we move on, that's where our decimal is going to come from. So I know that 3 times 75 was 225. We just did that. 225 out here to the side. All right, so 4 minus 5 is a no-go. So I got to go over to the 8 and borrow. Borrow from the 8, make it 7. Put the 1 with the 4. We have 14 minus 5, which is 9. Now I have 7 minus 2, which is 5. 2 minus 2 is 0. Bring down this 9. And I have 599. All right, so 599 is close to 600. That's almost twice as big as this.
So double it.
So double the 3 and try 6. Use those little tricks. Don't sit there and multiply 75 by everything. Although if you want to, you can. So 5 times 6 is 30. Put down the 0. Carry the 3. 7 times 6 is 42. 43, 44, 45. And then I have to ask myself if I add another 75 to that.
Yes.
5, 2. I can. So it's a good place to start, but I can do another one. So instead of 6, I'm going to add 1 more and make it 7.
That was 600.
And then we have 525. All right.
Oh,
9 minus 5 is 4. 9 minus 2 is 7. And then We're out of numbers, so what do we do now?
Add a 0.
Add a 0, and you extend that division line out. So add a 0, bring that down. I now have 740. So remember that this number was when I did 7. So I'm going to have to go a couple bigger than 7, don't you think? Here's another thing. What if I took 75 times 10? How big would I be? 750. That's a little bit too big, but not that far. So in my mind, I'm going, okay, it's going to be 9. So just down here in the margin, I'm going to take 75 times 9 and work it out. 5 times 9 is 45. 7 times 9 is 63, 64, 65, 66, 67. So 675. So you put the 9 up there, subtract 675. Hold on to your hats. This one's going to be a little bit. So we're going to subtract 675. So borrow from the 4, make it 3, make this 10. 10 minus 5 is 5. And then 3 minus 7 I can't do, so I got to borrow from this 7 and make that 13. Minus 7 is 6. We are almost done. We're getting there. We're not there yet. Got to add another 0. We get 650. So I might look back and go, okay, this was 9. And this was 7. It's kind of in between there. So it's probably going to be 8. So I'm going to go ahead and write 8 down, and then I've got to do 8. So yeah, we did have to do a whole bunch of 75s. So it's okay. So 75 times 8. 5 times 8 is 40. Put down the 0, carry the 4. 7 times 8 is 56. Plus 4 is 600. So I'm going to put an 8 there. 8 times that is 600. We are almost there, I promise. And it's okay to go down to the next box a little bit. So I'm going to get 50 when I subtract, and we just have to bring down one more 0. We get 500. Or wait, maybe we're not. We're almost there. So we're not there yet. We had 450 up here when we did 6. So I'm going to put a 6. Make it 450. Subtract, and I get 50 again. What's happening there?
Repeat.
It's going to start repeating. So I'm just going to put a repeating bar over that last 6. Oh my gosh, that took forever. But it's doable. And having your scratch work in a way that you can go back and maybe use the same multiplication facts again and again. You might have to use some of them more than once or use them to estimate the next one. So you want to have that written somewhere where you can read it. So let's think about this. Remember, we're talking about dollars per gallon. So we have this huge decimal. So I haven't even answered this yet. So we have this huge decimal. We're going to round off to dollars and cents. So I'm going to have $3 and how many cents? So I have to round off to 2 decimal places. So I'm going to look at the 9. Is it going to round up or stay? It's going to round up because I have an 8. So the 9 rounds up to a 10, which makes the 7 an 8. And our final answer is going to be 380.
Oh, that for 3 numbers?
So what we're going to do is we're going to check this number that we had up here with the calculator. Thanks. And so if we check that with the calculator, we're going to take your 28.49. We're almost done. I'm sorry. Divide it by 7.5. And we did get the same number that we got up here. And so it is 3.798 with the repeating. We're going to check it off.
No, it doesn't repeat.
Oh, I'm sorry.
3.7986 repeat.
86. You're right. 86, and the 6 is repeating. So that checked out. The rounding part's the only thing the calculator won't check. So, thank you for sitting through that. We're going to finish this tomorrow, and then you're going to get an assignment. And so hopefully we'll get through this, and you'll have at least half an hour to work on it in class. So since I'm not giving you homework tonight, make sure you are checking GoEduStar today. Make sure you're getting stuff turned in if you've not turned in all of your assignments. Thanks, guys. Have a good day.